Hello and welcome back to my channel, as it were, and today we're going to be continuing the TMUA paper we started last week, and we're going to be starting at question 3. So we are told that the line L, I'm going to call it L1, is equal to, it has y equals to 6 minus 2x, so that's going to have a negative gradient and is going to pass, I'm just going to redraw that line, and is going to pass through 0, 6, and also I can work out the x-intercept will be, so when y is equal to 0, 6 minus 2x, so therefore minus 6 is equal to minus 2x, x is equal to 3. Okay, so it will pass through those points, so that's my line L1. And then we're told that L2, a second line, is perpendicular to L1, so that means that its gradient will be equal to a half x, because we have it has to be the negative reciprocal of the gradient of the other line to be perpendicular. So it is perpendicular to L and passes through the point minus 6, 0. So it has the equation y is equal to half x plus c. This is just your basic y equals mx plus c. And it passes through the line y, so yeah, passes through 0 is equal to minus 6 over 2, which is minus 3, plus c, therefore c must be equal to 3. So our equation for this line is y is equal to x over 2 plus 3. And the y values will be the same for these two lines which intersect at this point, not necessarily on the axis, so that line's not correct. I'm going to draw that through there. So I want to calculate the area of the triangle that was there. I want to calculate the area of this triangle, is what the question is asking me to do. I probably should have mentioned that at the start. So, x over 2 plus 3 will be equal to 6 minus 2x. So first of all, I'm going to multiply both sides by 2 to get rid of this fraction here. And that's going to give me x plus 6 is equal to 12 minus 4x. Then rearranging, that is 5x is equal to 6. Therefore, x is equal to 6 over 5. Now, because I've got a fraction, I'm going to check just that I've got this right. Looks good so far. 5x, yeah. Yeah, it looks good. So, and then I'll substitute that into my previous equation. So y is equal to 6 minus 2x, which is equal to 6 minus 12 over 5. 6 is just 30 over 5, so 30 minus 12 is 18 over 5. So y is 18 over 5 at this intersection, at E intersection. So the area of the triangle enclosed by the two lines and the x-axis will be equal to half the base times the height. So the area will be equal to half times the base, which is from minus 6, 0. We were told that this line here intersects the axis at minus 6, 0. And also 3, 0. So it has a base of 9. So half times the base times the height, and that will be equal to, so 9 over 2 times 18 over 2, so 9 times 18 can be split up as 9 times 9 times 2, which will cancel with the 2 here. So I'm going to rewrite this as half times 9 times 9 times 2 over 5. Because it's all multiplication, this 2 will cancel with this 2. And that just gives us 81 over 5. And I need to find that as a mixed number, because my options are solely mixed numbers. And so that will be equal to 16 and 1/5. 16 and 1/5, which is answer A. So then next, question 4. In question 4, we are told that 3x squared plus 8x minus 3 is multiplied by px minus 1. And then the resulting product is divided by x plus 1. And the remainder, so that will be equal to a whole number n, so n belonging to the integers, plus 24 over x plus 1. So we're told that 24 is our remainder. What is the value of p? So the way we're going to do this is we're first going to multiply this bracket and this bracket, and that will give us 3px cubed minus 3x squared plus 8px squared minus 8x minus 3px plus 3. And I'm going to factorise this. 3px cubed minus I'm going to treat this, so I'm going to say plus 8p minus 3 x squared, just pairing my x squared terms, minus 3p plus 8x plus 3. And I'm told that when I divide this by x plus 1, I will get a remainder of 24. Now what I'm going to do here is I'm going to use remainder theorem. A remainder theorem states that if you do f of minus 1, which in this case, or if you do f of the root that it would produce, so if it's x plus 1, then you use f of minus 1, which is just your factor theorem, but it actually can be used for remainder theorem. So f of minus 1 will be, so 3p times minus 1 cubed is just minus 3p, plus 8p minus 3, because negative 1 squared is just 1, minus, so actually that's going to be a plus 3p minus, no, plus 3p plus 8 plus 3, and that is all going to be equal to 24, because that's our remainder, and that's the rule of remainder theorem. So this 3p here will cancel with this 3p. Then we have 8p, this minus 3 will cancel with this plus 3. So 8p plus 8 is equal to 24. Therefore, 8p is equal to 16. Therefore, p is equal to 2, which is answer B. Thank you very much for attending this video, and I look forward to seeing you all next time.